Hey guys, let's go over D10. D10, we're down below. We're trying to solve this quadratic systems, and we're going to use the substitution method. So let's go ahead and use the substitution method. Let's do that. Okay, what does that tell us? I like to use a highlighter. Every time you see the y, you can write 2x squared plus 4x minus 7. We're going to replace this y with what I just wrote there in red. So instead of writing y, we're going to write 2x squared plus 4x minus 7. And everything in blue here is going to be the same. Okay, I like to draw a line down my equal sign to try to make things look clean. Okay, so now I got to set it equal to 0. How do you set it equal to 0? You can either move everything to the left or move everything to the right. And you have to think strategically. If I move everything to the right side, I'll have a subtracting of minus 2x squared. Let me just show you this. And I don't really want this because I'll have a negative x squared, and then I can't really factor that. Does that make sense? So I'm not going to do that because Miss Ream just said that would not be wise. So let's not do that. Okay? Those supposed to be red. Okay. So let's move everything to the left side. Left side. Let's do that. So I'm going to subtract 1x squared. I'm going to subtract 2x. And I'm going to subtract 1. 1 minus 1, 0. 2 minus 2, 0. 1 minus 1, 0. Okay? Let me just do this right here. So I get 1x squared, or just x squared. 4 minus 2 is 2, and negative 7 minus 1 is negative 8. I now have something set equal to 0. Okay? What do we do next? Let's test our discriminant. The discriminant, is, this comes from the inside of the radical sign in the quadratic formula. And I'm looking at the a, b's, and c's I'm getting from are from here. So we're just going to substitute that into there, okay? So my b value is 2. My a value is 1, and my c value is negative 8. So if I simplify this, and we're going to compare this to, 0. And 36 is greater than 0. What does that tell me? There's going to be 2 real solutions. 2 real solutions, okay? That means it's going to cross or intersect 2 intersections. That's what it means. So let's not forget that as we do the rest of this math over here, okay? So we've done the discriminant. Now we're going to solve for x. How do I solve for x over here? We're going to see if we can factor. So a times c is negative 8. B value is 2. My two numbers that multiply to be 8 are 4 and 2. But I need a negative number, and that's going to have to be negative 2. So 4 times negative 2 is negative 8. For 4 plus negative 2, or 4 minus 2 gives me a positive 2. So that works. Okay. So this is what we have. X plus 4 and x minus 2. Remember, if you were with us in the beginning of the year, we said that this is our way of factoring. Factoring is a hard skill, so go back, type in factoring trinomials into my math channel, and then you're going to see a ton of examples. This is a skill, and that's why I spent so much time on it, guys. Remember, you only have to use the x when a is equal to 1. Okay? All right, so we need to solve for x here, and all you need to do there is just set each of these equal to 0. This is called the ZPR. Zero product rule, which means you set each of these equal to 0. Whatever's on the left side over here, you set it equal to 0. Okay? So if I subtract 4, I get x equals negative 4 as one of my solutions. Use red. And then over here, I add 2, and we get x equals 2. Okay? So what we've done so far is we've just solved for x. We now need to solve for y. How do we do that? Well, you use one of your original formulas, original equations, right there. Okay, I'm going to pick one that has smaller numbers, and I think this one looks good. I'm going to use this one. Okay, so let's use it. I'm going to write that twice. Okay, I can't see it. I always do that. F of x equals x squared plus 2x plus 1. You might be asking, where did I get the f of x? It's the same thing as y, but I just want to show you guys function notation. Why do I want to show you guys function notation? Because you need it, and students struggle with it. So if you see it more, it doesn't become difficult. So if x equals negative 4, that's the number I'm going to put in for every value that's x, negative 4. See that? And then you just do your substitutions. So you have f of negative 4 equals negative 4 squared plus 2 times negative 4 plus 1. And then we just go and simplify. Negative 4 squared is 16. 2 times negative 4. Remember, that's not 2 minus 4 because there's no plus right there. So multiply. And 16 minus 8 is 8 plus 1 equals 9. So this is actually an order pair. That's your x, this is your y. Negative 4, 9 is one of our intersections. Okay? Let's double box it because that's our final answer. Okay? Let's do the same thing over here. I'm now going to put in x equals 2 for every time I see x. Let's do it together. F of 2 equals 2. So every time I put it in parentheses, this is a parentheses, this thing, right there, okay? And then we just go back and simplify. F of 2 equals 2 squared, which is 4. 2 times 2 is 4, plus 1. So you're going to get f of 2 equals 9. So my order pair we're going to get is 2, 9. Okay? So let's transfer those up on our graph. Okay, remember this is our x. Did it again. X, this is our y. And we're going to put up our points of intersection. 2, 9. Right to up 9. 2, 4, 6, 8, 9. And the other one, so we just did this one. And then the green, negative 4, 9. Negative 4, 9. 0, negative 1, negative 2, negative 3, negative 4, right there, okay? So I know my graphs have to go through that point, okay? Let's graph it. This one, in red, let's see if it's factorable. Actually, no, that is the case. A times C is 1, B value is 2. My two numbers are 1 and 1. So that is x plus 1, x plus 1. And that's in factor form. So remember, if you just set it equal to 0, you will get x equals negative 1, which means it's a double root, right? It's the same number there. That basically just means if you go to negative 1, that's what I'm graphing right there. And then a y-intercept of 1, my graph's going to look something like this. Now remember our symmetrical points. It's got to go, sorry, I was saying that because I kind of need to go through that blue point. Does that make sense? Alright, there's my red graph. Let's do a purple graph. I'm going to quickly see if I can factor that. Negative 14 and 4, so I'm thinking 14 and 1, 7 and 2 doesn't, so that means it's not factorable. Okay, if it's not factorable, you're just going to have to use the attributes or plug-in points. So negative 7, there's the origin, 1, 2, 3, 4, 5, 6, 7, there's negative 7, there's my y-intercept. I know that because of that negative 7. I know the graph is going to open up. Remember, that's not my vertex, but we can just kind of expect my graph to kind of go through that point. Now, it looks like it's touching all the way, but I'll show you when we use the technology that those are our 2 points of intersection. Okay, so let's go ahead and graph those. Again, here's a plug to the calculator I use, graph and calc 83. Found it, liked it, works. Okay. You can also use Desmos. I'm going to use 2x. Okay, some of you guys like the exponent. Fine, use the exponent. Plus 4x. Remember, it's the y-x, not the green x on the screen there. Minus 7. And this one is x squared, plus 2x plus 1. First one is a green, and then the red. Press graph, and there you see it. There's our points of intersection. And you can even do that. Look at that. Boom. 2, 9. Isn't that cool? Boom. Oh, I missed it. Boom. Negative 4, 9. Oh, yeah, I got it. Okay. So 2 of them. 2 points of intersection. Told it by us by the discriminant. See you guys.